In this video, I want to talk about 3D shapes. And a 3D shape, or three-dimensional shape, is just a figure that has three dimensions. And we are already familiar with two of them, right? So if we had a square or rectangle, we would already know, that this is the length and this is the width. But when it comes to 3D shapes, we are going to have a height, or what is sometimes called depth. So notice how we already have this square right here, but we want to know how tall or how much volume it takes up. So this, or rather all of these lines, are going to be the height of the shape, and we sometimes call this depth. But it is important to know that unlike 2D shapes, which lie flat, 3D shapes are going to take up volume. They're going to take up space. And something very important to take notice of is that 3D shapes, and I'll write this again, 3D shapes are defined by three things, right? They're going to be defined by what's called the face, the vertices, and the edges of the shape. And a face is simply just the flat parts, or the two-dimensional parts, right? So a face could be right here, right? This front face. This area right here. This is called a face. And you'll notice that this shape has six, right? So it's going to be this front face, the back face, the two side faces, and then the top and bottom face. And then edges are where two faces meet. So if you look at this shape, the lines where the squares come together are edges. So this right here, and I'll draw a straight line, this right here is going to be your edge. And we have multiple of those, so this here is an edge as well. And then your vertices are the corners where the edges meet. Like here, the sharp corners here are going to be the edges. So this is an edge, this is an edge, and then this is an edge. So the faces are the flat parts, the edges are where two faces meet, and then the vertices are going to be where two edges meet. So let's try to count the faces, edges, and vertices of this shape. So like I already pointed out earlier, if we take this front face here, that is one face, and then back here, I'll try to draw this as well as I can. Back here is going to be another face, and then the sides here are going to be two faces. Oh, sorry. They are going to be two faces right here, and then these top faces are faces as well. So the sides, the front and back, and the top are going to be six faces. So I'll just say F is equal to 6. Or let me get rid of this first, and then F is equal to 6. And then for the edges, we could just count up here, right? So this is going to be 1. This is not perfect. 2, 3, 4. And then you'll notice the top and bottom both have 4 edges as well. So it's going to be 1, 2, 3, 4. So in total, this is 8 now. And then we'll have 9, 10, and again, that's not perfect, 11, and 12. So edges, there are 12 of them. And then vertices, we can see here this will be 1, 2, 3, 4, 5, 6, 7, and 8. So this is our answer here. There are 8 vertices. There are 8 vertices. So now I want to point out a unique property of shapes. And you don't necessarily need to know this, but it's just something fun to realize. So if we take the faces and the vertices and we will add them, so faces plus vertices, and here I have already counted up the faces, edges, and vertices, and then we subtract from that the edges of the shape, this is going to be equal to 2. And this will hold true for any three-dimensional shape or polyhedra. So here we are going to take faces, which is equal to 6, vertices, which is equal to a, and add them, and then we're going to subtract by 12. And this will give us, hopefully, 2. So 6 plus 8 is going to be 14, minus 12 is, in fact, 2. So that is our answer here. So just something unique for you to realize, and this is called Euler's equation. So if we take the faces plus the vertices and subtract the edges, we will always get 2. So let's work on one more example, and we're going to do the same thing as last time. So let's just count up all the faces, edges, and vertices. So here we'll notice that there are two front faces here. So this face here, or sorry, one front and then one back, because there are two triangles here. And then there are going to be three faces on the side. So we have this face here, we have this face here, and then we have this face down at the bottom. So that is going to be in total 5 faces. So f will be equal to 5. And then we are going to take the edges, right? The edges, and that's a rough looking E. We're going to take the edges. So let's just count these up. So we have 1, 2, 3 on the front and back. And then we are going to have one here, and one there. So that's going to be, let's see, 3, 6, 9 edges. And then the vertices are going to be 1, 2, 3, 4, 5, 6. So vertices is equal to 6. And we can use Euler's formula, a fun trick. So we can take the faces, which is 5, plus the vertices, which is 6, minus the edges, and this should be equal to 2. And you can always use this to check your work. So this is going to be 11 minus 9, and that does in fact equal 2. And we are done.